Hallo, it's Dumplet here. Here's an item on algebra. A and b are real numbers such that a over b squared plus b over a squared equals 1 over a plus 1 over b. Find all possible ordered pairs of ab. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now here we have like a nice equation. It's kind of symmetric with a and b. And we have denominators, so generally want to avoid denominators so it's easier to work with. Maybe we can factor, or maybe we're going to end up with like a nice expression. But don't forget that whenever we try to clear denominators, we always go back to the original equation because, for example, here we might have restrictions like the denominators, well, they can't be 0. So just in case, we're going to do, in this case, like we're going to multiply both sides by the LCM, in this case a squared b squared. Don't forget to always go back to the equation. Maybe you're going to check the domain or any possible restrictions there might be. Anyway, so for our first step, let's multiply both sides by a squared b squared to clear the denominators. So we can work with the equation a little bit easier. So the first term becomes a cubed. The second term becomes b cubed. Then equal sign. 1 over a, this becomes ab squared. Then 1 over b, it becomes a squared b. Now on the right hand side here, I can just make it a squared b plus ab squared, since addition is just commutative anyways. And then I kind of want to put everything on one side because we might be able to do some factoring here. So let's subtract both sides by a squared b plus ab squared, and that's going to give us a cubed plus b cubed minus a squared b minus ab squared. And then the right hand side is going to equal to 0. Now, I'm going to rewrite these terms in a certain order. A cubed minus a squared b minus ab squared plus b cubed. And then the reason why I want to write it this way, it's because we can take note here that in the first two terms, we have common factor of a squared, right? I can factor the a squared out, and I'm going to end up here with a minus b. And then in this third and the fourth term, I'm going to factor negative b squared. Again, it's intentional. I'm going to factor out negative b squared, and I'm going to also end up with a minus b. Then we have the equals 0 over here. Now, so here what we did is we technically factored by grouping, and then we got another common factor of a minus b between those two numbers that we actually factored. So we can again factor the a minus b, as you can see here. They both have a common factor of a minus b. We can factor the a minus b out, and then a squared minus b squared over here. And then we have it equal to 0. Now we can do some further factoring here because, as you can see here, a squared minus b squared, that's just a difference of two squares. That's going to be equal to a minus b times a plus b. And then since I have two a minus b's, I'll have a minus b squared, and then the a plus b here is just the a plus b here. So a minus b squared times a plus b, that's going to equal to 0. Now, we're going to use the 0 property because we have some products, we have some expressions that multiply to 0. So I'll have two possible cases here, a equals b from the a minus b case, or the second case, a equals negative b. All right. From these two, I can just say, oh, generally, I can just make a, for example, k, and then, well, if a equals b, then my b should also be k. And that's going to give us the first set of ordered pairs here. And then the second ordered pair, I can still make a k, but that's going to make b negative k. And that's the two general ordered pairs we see here. But then again, we always have to go back to the original equation because we technically have some restrictions, particularly in the denominators. Well, we know that none of these denominators can equal to 0, so we're going to make it equal to 0, and those are the values that we must restrict. Now, b squared equals 0, a squared equals 0, a equals 0, b equals 0 is just the same thing as saying a equals 0 or b equals 0. So we cannot have a or b being equal to 0, so we want both of these to not equal 0, and therefore the only way we can make these four numbers, the k, and negative k, not be equal to 0 is to additionally include this restriction over here. So k is a real number because at the start we're asked to solve over the set of real numbers, and then we have to exclude 0, or we can just simply say k not equal to 0. So our final answer here would be k comma k and k comma negative k for all real numbers k that are not equal to 0. And this will be our answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!